Good morning, students. Today I welcome you all on behalf of Rasa International School. Today we will study Maths, Class 10th, Chapter number 2, Polynomials. In this, we will discuss about polynomials. What are polynomials? So, polynomials are either of one variable or two variables or three variables. Suppose if I write 2x, if I write 2x plus 3y, then this is of a polynomial of kind 1 variable and this is of a polynomial of kind 2 variable. Why two variables? Here we have the variable x and y and here we have the variable only x. Now whether it is a polynomial or not, if the variable is having power in whole number only, then you can say that it is a polynomial. Otherwise you can't say it is a polynomial. So here you can see that we have the example over here, 4x plus 2. In 4x plus 2, the x is having a power of 1. So we and 1 is a whole number, so we can say it as this is a polynomial of variable x and whose degree is 1. Now why I am calling the degree as 1? I am calling the degree as 1 because the maximum power of the variable in a polynomial is known as degree of that polynomial. Okay, so here you can see that the highest power or the maximum power of the variable x in the polynomial px is known as the degree of the polynomial. Clear? So now we will come to discuss about what are linear polynomials and quadratic polynomials and cubic polynomials. Linear means degree 1, quadratic means degree 2 and cubic means degree 3. Now you can see these are the polynomials whose variable having the maximum power in the polynomial as 1. See over here the x is having the power 1, over here x is having the power 1, y is having the power 1, x is having the power 1, z is having the power 1, u is having the power 1. So I call them as linear polynomials. On the other hand, the polynomial with degree 2, they are known as quadratic polynomial, like 2x square plus 3x minus 2 upon 5. Here the maximum power is 2. You can take an example of like this also, 4x square minus 9. This is also an example of quadratic polynomial. Now we are moving towards cubic polynomial. Here the polynomial will have a maximum power as 3. So let us see some examples of it also. So here you can see that 2 minus x cube, x cube. So these are the kind of cubic polynomials. Clear? So now we will discuss about the zeros of the polynomial. We also call them as the roots of the polynomial. Okay. So suppose you have a value of a polynomial over here is x square minus 3x minus 4. So this is a polynomial. We have to find a value of x for which this polynomial at that value of x will become 0. If it is become 0 at that value of x, at that value of x, let it value be a, then I say that this a is the root or 0 of this polynomial. Okay, let us take an example so understand it clearly. So this is our polynomial. Okay, so now I'm taking a value x is equal to k and instead of k we are taking minus 1. Now at the place of x in this polynomial we place value of x as minus of 1. So we will get minus 1 square, 3 into minus 1 and minus 4. So see it is written over here. So minus 1 square is 1, 3 into minus 1 is plus 3 and minus 4. That means plus 4 minus 4 is equal to 0. That means I can say that p at minus 1 is equal to 0. Therefore I can say that minus 1 is the root, or you can say 0 of this polynomial, or 0 of this quadratic polynomial. Understood? Now how we represent the root of a linear polynomial? Okay, so root, or you can say the zero of a linear polynomial. So if linear polynomial of the form is ax plus b, okay, for any value of k, okay, x equal to k, let pk, that p at x is equal to k, is equal to 0, then you can get the value of k from the equation as minus b upon a. So this is known as the zero of this linear polynomial, where minus of constant term. Now what is constant term? The constant term is the term which don't have any variable along with it in the equation. So b is not having any variable along with it. Okay, so b is the constant term, so minus of the constant term upon coefficient of x. Now that we know already, we discussed in class 9, that suppose the equation is 2x plus 3, then we can say that 2 is the coefficient of x, okay, and 3 is the constant term. If in place of plus it is minus, then I will say that constant term is minus of 3. Okay, we have to consider the sign along with the coefficient. Clear? So now we will proceed to geometrical representation. This is what we have done, the calculation of zeros from the equation. Now we will do the geometrical representation of the zero. So geometrical representation, or geometrical meaning of zeros of the polynomial. So let us discuss about the zeros of a polynomial. So suppose we have a polynomial y is equal to 2x plus 3. So if you take any two values of x, suppose let it be minus 2 and plus 2, then you will, when you solve them, okay, so let me solve one. Y is equal to 2x plus 3. So we have took x equal to minus 2, so we will place 2 into minus 2 plus 3, so it will be minus 4 plus 3, and it will come out to be minus 1, so it has been written over here. Similarly, when you place x equal to 2, you will get a value of y equal to 7. Now you plot these values on the graph. Okay, so it is over here minus 2 and minus 1, and 2 and 7. So when you plot them, you will find the graph will pass through the x-axis. When the graph is passing through the x-axis, then you will be getting the zero of the polynomial. Okay, the zero of the polynomial is on the x-axis. So where the graph cut on the x-axis, that value of the x at x-axis will be zero of the polynomial. Okay, so here the graph cut the x-axis at minus 3 upon 2, so the value of 0 is minus 3 upon 2. Clear? Now we will proceed to, so because it is a linear equation, so we are not getting zeros more than 1. Okay, now let us discuss about a quadratic equation. Here the quadratic equation is of the form ax square plus bx plus c, and the equation we are using, okay, here is x square minus 3x minus 4, x square minus 3x minus 4. When you plot the graph for this equation, you will find two zeros. Why? Because this is a quadratic equation, and in a quadratic equation there are two zeros. Maximum you can have two zeros, means the value of degree is equal to the maximum numbers of 0. Okay, means at most you can get these many zeros. Clear? Now we can do further. Okay, moving towards the polynomials in which we are getting two zeros. Okay, so here the graph, you are able to see that the graph will cut the x-axis at 2 points. That means there are two zeros of this polynomial. Similarly over here it is also cutting at two points at x-axis, so it is having two zeros. Clearly you are able to see that. Okay, now you are able to see that here the graph, it cuts the x-axis only at one point, both of them, so it is having only one zero. Okay, the quadratic equation is having only one kind of zero. So the x coordinate, okay, the x coordinate of a is only 0 of the quadratic polynomial. So that means both the values of the zeros are same. Clear? But the at most you can get two zeros for that quadratic polynomial. Now here you can see that this equation doesn't have any 0 because it is not cutting the x-axis at any point. Are you able to get this? This here the x-axis is not been cut by the graph, so this quadratic polynomial has no 0 in this case. Clear? Means a quadratic equation can have at most, okay, at most two zeros, okay, clear? And they can also having 0, there's no 0, 1 0 or two zeros, okay, that we have seen. Now you are able to see the equation which is a cubic equation over here. You can see now we have a cubic equation x cube minus 3x, sorry 4x. Now for this equation you are able to see there are three zeros because this is a cubic polynomial and the degree is 3. Understood? Now here also you are able to see that there's a cubic polynomial, but we are getting only two zeros, only two zeros. Understood? So the number of points on the x-axis which have been cut by the graph is the zeros, count of the zeros of the particular polynomial. Understood? Now we can conclude them. Okay, note that 0 is the only 0 for the polynomial x cube that we have seen in the previous diagram, that is 2.7 figure. You can see that 0 is the x coordinate of that, the only point where the graph y equal to x cube intersects the x axis. जितने पॉइंट पे ग्राफ x एक्सिस को कट करेगा या इंटरसेक्ट करेगा उन्हीं को हम उस पॉलिनोमियल्स के जीरो कहते हैं. ओके, so similarly this value, the zeros are 0 and 1 for the graph which we have seen over here. There are two zeros, that is 0 and 1. Understood? So these values are the x coordinate of the only points where the graph this intersects the x-axis. Okay, so it has been concluded over here that from the example above we can see that there are at most ज़्यादा से ज़्यादा तीन जीरो हो सकते हैं cubic polynomial के. In other words, any polynomial of degree 3 can have at most three zeros. ज़्यादा से ज़्यादा तीन जीरो हो सकते हैं, उससे ज़्यादा नहीं हो सकते. Means the degree of the polynomial is equal to the maximum number of zeros that polynomial can have. Okay, so now discuss about these questions, which is example number 1. Okay, now you can see that over here how many points at on the x-axis the graph cut 1. So the number of 0 it will have 1. It will have 1 2. It will have 1 2 3. Okay, it will have only 1. It will have only 1. It will have 1 2 3. Okay, let me make the screen big so we are able to understand this. Okay, now we have to see this. How many zeros it have? 1 2 3 4. Okay, understood? The four points it will cut at the x-axis, that is why it is having the values of zeros as 4. Understood? So first one is having how many zeros? 1. Second one 2. Third one 3. Fourth one 1. Fifth one 1. Sixth one 4. Clear? Now similarly you can do the exercise 2.1 and solve it in your copy. Okay, if you have any doubt you can comment on this video and update me so I can respond. You also get the answer sheet for this. Okay, so check it out and try it yourself. Thank you.